Alright guys, welcome to day 4 of week 5 of chemistry in quarantine. I'm outside because it is so gorgeous out here, and Ireland would not stop crying unless I brought her outside. So she loves it out here, so that means I do too. Alright, so we are going to continue our discussion on redox reactions. So remember we talked about redox reactions are any type of transfer that's happening with electrons. So whether something is whether an electron is being moved from atom to atom, whether it's gaining it or it's losing it, that's a redox reaction. So if something's being oxidized, something has to be reduced. Now remember, the difference between being oxidized and being reduced is oxidation is actually a loss of electrons, while reduction is actually a gain of electrons. So if that already has blown your mind, make sure that you go back to day 3 video and watch that, and make sure you know those mnemonic devices. So oil rig, so oxidation is loss of electrons. Rig, so that's the oil, oxidation is loss. Rig is reduction is gain. Or you can do Leo the Lion says GR, which is Leo is loss of electrons is oxidation, or GR, which is gain of electrons, is reduction. So either way you remember it, it'll stay with you forever. And yeah, so just be sure you have those two things completely figured out in your brain, because now we're going to get a little bit deeper into it. So before we can actually balance redox reactions and use oxidation numbers and figure all of that out, we have to talk about a couple more things. One of the things we have to talk about is what's called oxidizing and reducing agents. Okay, so an agent makes things happen. So if you think about, my agent called or whatever, that's the person who's in charge of somebody else and makes something happen. So an oxidizing agent makes oxidation happen, and a reducing agent makes reduction happen. And I know that sounds easy, but it's really easy to get it mixed up with what's being oxidized and what's being reduced. This is what I mean. To make oxidation happen, something must take electrons from it, okay? And to make reduction happen, something must give electrons to it. So this is gonna be crazy, but just look at that picture of, just focus your attention on the circles A and B. So those represent two different atoms, and A is giving up an electron or losing an electron and giving it to atom B. Atom B is taking an electron or gaining an electron. So atom A is being oxidized because it's losing an electron. Atom B is being reduced because it's gaining an electron. Okay, so A is being oxidized, but we said before that an agent is something that makes something else happen. So an oxidizing agent makes oxidation happen. A reducing agent makes reduction happen. So in this problem, atom A is being oxidized, but because of its oxidation and its losing of an electron, it is giving its electron to what is being reduced. So A is actually the agent that is responsible for reducing atom B, right? So A is actually the reducing agent. On the flip side, atom A is taking the electron from, or atom B is taking the electron from atom A, and it's oxidizing atom A because it's taking from atom A. So even though atom B in and of itself is being reduced, it is responsible for oxidizing or taking away atom A's electron. The thing that is oxidized is the reducing agent, and the thing that is reduced is the oxidizing agent. Okay, so the thing that is oxidized, which in this example is atom A, is the reducing agent because it is giving up its electron, it is losing its electron and giving it to atom B. So it is saying, hey, I am going to reduce you. So I am being oxidized, but I'm going to reduce you. I'm going to give you an atom. You're going to gain an atom. I'm going to lose an atom. Whereas on the other side, the thing that is reduced, atom B, is the oxidizing agent. So it is being reduced, it's gaining an electron from atom A, and in that gaining of an electron from atom A, it's the oxidizing agent. So it's taking the electron from atom A. So it's oxidizing A. So, kind of makes sense, right? But you have to, that's why it's so important to get the beginning part, the oil rig and Leo the Lion says grr, that's why it's so important to get that right, because otherwise you will be completely lost when it comes to agents. It's important to realize that when oxidation occurs, a loss of an electron is happening, so your oxidation number actually increases. With reduction, it's a gain of electron, your oxidation number actually decreases. So we use this example in day 3 of the video, but imagine I have a chlorine atom. Let's say I add an electron to it. An electron has a negative charge. So if I add -1 electron to my chlorine atom, it's going to be chlorine with a -1 charge, right? If I were to add another electron on top of that, now I would have a chlorine with a -2 charge, because it has 2 negative charges being added to it, or 2 negative electrons being added to it. So what it means is, 1, 2, 3, 4, 5, 6, 7 is higher numbers in value than -1, -2, -3, -4, -5. So if this is my 0, 1 is of a greater value than -1, right? So it's saying when you gain electrons, that oxidation number is actually going to decrease. That's why we call it reducing. So the oxidation number itself is actually reducing. When an atom loses an electron, the oxidation number actually increases. So our last slide of the day is going to be an example. So with that in mind, an oxidation is loss of electrons, so my oxidation number increases, that's what ON stands for. With reduction, it's a gain of electrons, so my ON, or my oxidation number, is going to decrease, okay? So let's take a look at this problem. So we have calcium plus chlorine, 2 atoms of chlorine, going to react to produce carbon dichloride. We interrupt this broadcast to let you know that several times during this next example that you're about to see, I say carbon dichloride and I refer to Ca as carbon. Ca is definitely not carbon. Carbon is written as just a C. Ca is calcium. So please just know from here on out, if at any point I refer in this problem to carbon, I'm actually speaking about calcium. Really sorry about that. I just caught it as I was putting it on YouTube. So hope it doesn't mess anybody up. If it does, let me know and I'll get you. You already know how to do this. So what is the oxidation number of calcium? Well, we know if an if an element is by itself, all by its lonesome, and not paired with a different type of element, that its oxidation number is always going to be 0. It doesn't matter how many atoms there are. So for both calcium and for chlorine, my oxidation number is going to be 0. On the other side, the right side of the arrow, we have our carbon as our oxidation number for carbon is +2, and our oxidation number for chlorine is -1. So in this case, at this point of the problem, we can figure out that calcium is being oxidized because when we look at calcium oxidation number from the left of the arrow to the right of the arrow, the oxidation number is increasing. What does that mean is actually happening? There's a loss of electrons happening. So calcium is actually giving up 2 electrons, +2 electrons. So calcium itself is being oxidized because it's losing electrons. Its oxidation number increases from 0 to +2. But calcium is the reducing agent, right? Because it is responsible for chlorine getting an electron from calcium. So it is giving its electrons to chlorine. So it's losing its electrons, calcium is losing its electrons and giving it to chlorine, which therefore is reducing chlorine, because reducing is a gain of electrons. So calcium is the reducing agent. On the other side, chlorine is being reduced. So we can tell from the left side of the arrow, we start off with an oxidation number of 0. From the right side of the arrow, now we have an oxidation number for chlorine, which is -1. So when that happens, when we see a reduction of the numbers, so remember 0 is here, -1 is going to be less of value than 0. The oxidation number has decreased, which means that a gain of electrons has happened. So when you see oxidation numbers and you see +2 or +4, that means that's how many that atom lost in electrons. When you see a negative, that means that's how many electrons that atom has gained. So in this case, chlorine has gained -1 electrons. Now technically, since we have 2 chlorine atoms in this problem, the problem's not finished yet, but that actually would end up being -2 because calcium dichloride is not a polyatomic ion, so you would want +2 - 2, which would make sense, right? Because you would multiply your -1 electron being gained times the fact that there's 2 chlorine atoms, just like we've done in the oxidation review. So it would be +2 - 2 equals 0, and we know that neutral compounds have an oxidation number equal to 0. So your chlorine is being reduced because it's gaining electrons, but it is responsible for oxidizing what? Oxidizing calcium, right? So it is the oxidizing agent. Because remember, you can't have oxidation without reduction, and you can't have reduction without oxidation. So if it helps you just to remember that the thing that is oxidized is the reducing agent, and the thing that is reduced is the oxidizing agent, if that's able to land in your brain and you don't really have to give it any more thought and you can just memorize it, then do it that way. But if you need to kind of critically think about it, be sure that you go back to day 3 video and then watch this video again. And if you have any questions, of course, you can ask me. But just remember that electrons are a negative charge. So when they get added to something, they're automatically going to reduce the value of the number. Okay, so you're getting more electrons, but since they're negative, that oxidation number is going to decrease. Alright guys, if you have any questions, please let me know. The start of next week, we will be talking about how to balance redox reactions. So be sure that you do your homework. It is due on Monday, April 27th. You also have a test coming up, which is going to be on May 1st, Friday, May 1st. So be sure that you are taking good notes, and if you have any questions, just let me know.